A child sits on a fiberglass bus grab fastened 8.3 meters from the center of a merry-go-round platform that is rotating once every 11 seconds. Part A of this problem wants us to find the child's speed while he's sitting on the bus grab. So what we can do first is draw a picture. So we have the merry-go-round right here, and it says that he is fastened 8.3 meters from the center. So from the center, he is 8.3 meters, and it rotates once every 11 seconds. So that is 11 seconds. So the given values that we have in this are the radius, which is 8.3 meters, and the time, which is 11 seconds. Now the formula that we can use given this information is the formula T equals 2 pi r over the velocity, which is what we're solving for. Now, since we're solving for the velocity, we want to move the velocity to the outside and move the time to the inside. So we have the equation V equals 2 pi r over V, or T, which equals 2 pi times r, which is 8.3, over the time, which is 11, and that equals to 4.741 meters per second is his speed. Part B of the merry-go-round problem asks us to find the child's acceleration while he is sitting on the bus grab. Now, since we already know the velocity, which is 4.71 meters per second, or 741, and the radius, which is 8.3 meters, we can use the acceleration formula of first centripetal motion of v squared over the radius, which equals to 4.741 squared over 8.3, which equals to 2.71 meters per second squared. That is the child's acceleration towards the center. For part C of the merry-go-round problem, we want to find the acceleration of the child if he moves to the rubber bison, which is 7.1 meters away from the center, instead of the muskrat, which is 8.3 meters away. Now, essentially what we want to do in this problem is do the same steps for part A and part B, but instead change the radius to 7.1 meters. So we start out again by drawing a picture of the merry-go-round. Here's the center, and the child is 7.1 meters away. And the time remains the same at 11 seconds. So we can use the same formula of V equals 2 pi r over T, which equals to 2 pi times 7.1, which is the radius, over 11, which is the time, and that equals to 4.06 meters per second. Now we want to reuse the acceleration formula from part B, given the new velocity and the radius. So we have A equals v squared over r, which is equal to 4.06 squared over 7.1, which equals to 2.32 meters per second squared. So when he moves to the rubber bison, he is now traveling around the merry-go-round at a speed of 4.06 meters per second, and he is accelerating towards the center at 2.32 meters per second squared.